Welcome to my channel for comprehensive tutorials on fundamental principles to complex problems. I'll cover it all. Feel free to share, subscribe for more contents. Thank you. Hello everyone, this is exercise 17D that you can find on page 330 if you have a textbook with you. In the previous exercise 17C, I have explained you how to find out the rules when the sequences are given. In here, we are going to learn general rules from pattern. If the patterns are given in front of you, how can you find out the rules to make the next shapes? Now in here it says the pattern of squares is built up from matchstick as shown, and if you notice in the first pattern it is one box only, and in the second shape 1, 2, 3 and 4 boxes are added, or you can say one box is added to each side of the box. Now look at the third pattern. In here you have 1 and 2, 1 and 2, 1 and 2, first and second. Like that, two boxes are added to each side. So if I want to draw the fourth pattern, I will be adding 1, 2, 3 on each side. And once they are counted all together, 3 this one, 3 this one, 6 this one, and this one, 12, and fourth is this one. 13 boxes are going to be made. So in here, I will write a 13. That means number square, you will have 13 in the fourth diagram. Now, the rule for this one, you can say our nth term, how do we draw nth term? Now you can see the difference is 4. That means 4n. So to make a 4, 1, I will be needing to subtract 3 from it. So this is going to be the nth term rule. Now, how many squares in the 25th term? Now, in here, same term rule is going to be for 25 minus 3. That means 25 times 4 is going to be 100 minus 3. That means your final answer is going to be 97. 97 squares are going to be in the 25th term. Now, they are saying with 200 squares, which is the biggest diagram that could be made. That means 4n minus 3 equals 200 squares. Let's see, 4n equals 197, and when 197 is divided by 4 is going to be giving us n. So that means 4 times 4 is 4 times 5 is 20, but 20 you cannot write, so that means 4 times 4 is 16, and 3 is going to go to 7. 4 times 9 is 36. Okay, so 49, that means you can draw on the 50th diagram you can make. There are 50 diagrams you can make. Now comes question number 2, which is over here. It says a pattern of triangle is made up from matchsticks. Now in here, if you see in the first box there are 3 matchsticks, and in the next one it has 1, 2, 3, 4, 5. So I'll write a 5 here, and in the next one there are 7, and in the next one it's going to be 9, and fifth one, if you count here, 1, 2, 3, 4, 5, 6, 7, 8, and 9 matchsticks. So or definitely in the fifth one it's going to be 11 matchsticks. Now for nth set of triangle, that means it's going to be giving us 2n, 2n, and plus 1. This is going to be the term rule. It says how many matchsticks are needed to make 60th set of triangle. That means 2 times 60 plus 1. So 120 plus 1, it's going to give you 121 matchsticks are going to be needed to make 60th set of triangle. If there are only 100 matchsticks, what is the largest set of triangle that could be made? Now 2n plus 1 equals 100 matchsticks, or it's going to be 100 matchsticks means it is going to be 60 plus 1, 121, and or you can say this way, 2 times n plus 1 equals 100. So 2n equals 99. That means n equals 99 divided by 2. So this is going to give us 49th set is going to be the answer. Moving on to question number 3, which is over here. As you can see the pattern in the first diagram, there are 6 tables, and the second pattern, it has 10 tables. In here, 14. So you can see the difference is 4. Okay. So okay, how many people could be seated for a table together? This way, 4 tables. That means the difference of 4 is going to give you 18. So answer for the first one is going to be 18, because the difference of each term is a 4. So the fourth term is going to give you an 18. Now in here, 6, 10, 14, 6, 10, 14, and 18. And the term rule, you can say, is 4n plus 2. Now there are 50 people. Okay, so 4n plus 2 equals 50. So 4n equals 48. That means n equals 48 divided by 4 is going to give us 12. So 12 tables are going to be needed if you wish to settle 50 people. Now in here, question number 4. In question number 4, it says pre-packed fencing unit comes in the shape below, made of 4 pieces of wood. There are 4 pieces of wood in the first shape. When you put them together in stages to make a fence, you also need a joining piece, so that fence will start to build up as shown below. As you can see, in the first shape there are 4 wood pieces. The second shape there are 8, but this is a joining one that keeps the fence together. When it comes to the third shape, this is the fence joiner that can join both the fence pieces. So every shape has different number of wood pieces. First one has 4, second one has 4, second one has 9, 4 plus 4 and 1. 8 plus 1 is 9. Now in the third shape you can see 4 is 3 times 12, and 2 pieces of this. So 13 is the number of wood pieces. So 4, 9, 13 is the sequence that you can see. 4, 9 and 13. As you can see, the difference between them is of 5. Okay, so that means 5n. So what should be you do to make a 5 a 4? You will subtract 1 from it. Okay, so this is going to be the term rule that I'm writing here, and using the same term rule, 5n minus 1, I will be changing this bracket with the 5, and in the last one I will make something like this. So this gives me 45 from here. 45 is going to come here, and here they need 5 stages. That means 25 minus 1 is going to be a 24, and this is going to be 225 minus 1 is going to be 224. Now part B, it says, I made a fence out of 124 pieces of wood. How many stages did I use? That means 5n minus 1 equals 124. Now 5n is going to be equals to 124 plus 1 gives you 125. Now n is going to be equals to 125 divided by 5, which is going to give you a 25 as an answer for this question. Moving on to the next question. It is about a pentagon In here, as you can see, it says regular pentagon of side length 1 centimeter are joined together to make a pattern as shown. Now, in the first one, you can see it is of 5 centimeter perimeter. Okay, so one of this 1, 2, 3, 4, 5 centimeters of one pentagon. When two are joined, you can count like this: 1, 2, 3, 4, 5, 6, 7, 8. It is giving you 8. Now look at the third one: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the sequence is something like this. In the first one, it is 1. In the first shape, it is 5. Second shape, it is 1, 2, 3, 4, 5, 6, 7, 8. It is giving you an 8. Look at the third one: 4 plus 4, 5, 6, 7. So altogether it's going to give you a 13. When you count here, it's going to be 11. Once you count for the fourth shape, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. As you can see, 14 centimeter will make the fourth shape. Now this is the sequence. In here, you can see the difference between all of them is going to be a 3. All these numbers have a difference of 3. That means you begin with 3. What you can do to 3 to make it a 5? That means 3n plus 2 is going to be the n number of pentagons. Now in here, I will remove this over here to make a space. And for 6 pentagons, it's going to be 3n plus 2. In place of n, I will replace n with a 6, like this one. And 18 plus 2 is going to give you a 20 centimeters, is going to be the answer for the shape with 6 pentagons. And pentagons, I've already given you 50 pentagons is going to be 3 times 50 plus 2. That means 150 plus, sorry, it's going to be 75 plus 2. So 152 is going to be the answer. When it comes to part B, it says what is the largest number of pentagon that can be put together like this to have a perimeter less than 1000 centimeters. So let's see, how do we do this? 3n plus 2 less than 1000 means just keep it 1000 and see. So that means n equals 998, and when n is divided by 998 by 3, so this is going to give you 3 times 3 is 9, 3 times 3 is 9, and 3 times 2 is 6. So 323. Let's check 323. 3n plus 2, and when 332, this is going to be 3n 332 plus 2. So this is going to give you 3 times 2 is 6, 3 times 3 is 9, and 3 times 3 is 9. So plus 2. That means 998 centimeters. That means our calculation of this 332 is correct. If we make 332 pentagons, it's going to be 998. If we make 333, it's going to be more than 1000. So 332 is the correct right answer. As it can be seen in question number 6, it says lampposts are put at the end of every 100-meter stretch of the motorway as shown. As you can see in the first figure, there are 4 lampposts like this one, 4 lampposts, and the second shape it has 6, and the third shape it has 8. So the difference is between them is a 2. That means 2n. So what you should do to 2 to make it a 4, you will definitely add to it. So this is going to be the answer for this part of the question 2n plus 2. Now comes for the first one. In here, if you put 4 plus 2, that means 8 plus 2 is going to be a 10, which is the answer of question number A. Then comes 8 kilometers. 8 kilometer means there are going to be divided by 10. That means 280 plus 2. That means 160 plus 2. So answer is 162. Now, when it comes to part B, it says new motorway is being built. The contractor has ordered 1,598 lampposts. How long is the motorway? Now, you will use the same rule. 2n plus 2 equals 1,598. Now, this 2 is going to go other side and becomes a subtraction. So, 1596. That means when it is divided by 2, it's going to give you 2 times 7 is 14, 2 times 9 is 18, and 2 times 8 is 16. Okay, so 798 when it's divided by 10 is going to give you 79.8 as the answer for this question. Moving on to question number 7, which is over here. It says that school dining hall had trapezium shaped tables. Each tables could seat 5 people as shown here. One, one, two, three, four, and 5. Okay. Now, when the tables were joined together as shown, uh, the individual tables can be seat many people. Now, in here, the first one has 5. So you can set a rule for this. First one has 5 seats. Second one has 3 plus 3, 6, 7, 8. Then comes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So as you can see, this is the sequence it goes. And in here, if I say the difference is a 3, that means 3n. And what you should add to 3 to make it a 5, it is plus 2. So this is going to be a term rule or n tables. So I should write this one here. Now, when it comes to 4 tables, I will write the same rule as 3n plus 2, which is over here. And in place of n, I will replace with a 4. So 3 times 4 is a 12, plus 2 is going to be a 14 plus 3 times 4 is a 12, and plus 2 is going to give us a 12. Now comes 13 tables, that means 3 times 13 and plus 2, that means 39 plus 2, which is going to give us 41 as the answer for this question. Now comes for an outside charity event up to 200 people. Now that means 3n plus 2 equals 200. Let's see what comes out. 3n equals 198 as 2 is subtracted from 200. So n is going to be equals to 2 times 3 times 6 is 18, and 3 times 6 is 18 again. So that means n is equals to 66, which is how many tables? That means 66 tables can be arranged for 200 people. Now, when it comes to question number 8, which is over here somewhere, yes. In this question, it says when setting out tins to make a display of certain height, so you must remember the height is 2 here, and height is 3, and height is 4 here. So 5 tins will have definitely 5. Okay. So and that means n is the only thing that you have, and 18 tins means 18 is going to be the height of the 18 tins high means 18 tins you will be needing. If the display is n tin high, the total number of tins is t equals n times n plus 1 divided by 2. So I'll make a little space out of here and bring this guy a little down. Now for B, you need to use this formula which is given over here. Now, in place of n, you need to replace 2 and 3 two different times. That means n is a 2 and then 2 plus 1 divided by 2. This is the first part. Then comes 3 and 3 plus 1 divided by 2. So, two different values you are going to get. So, 2 is going to multiply by 3 divided by 2, and 2 is multiplied by 4 and divided by 2. So, that means you're going to get 6 over 2 and 8 over 2, which is going to give you 3 and 4 as the answer for question number B. Now, how many tins will be needed to make a stack of 10? 10 tins high. That means it is going to give you for 3 and 4. It is going to be 10 as the answer. Now comes question number 9, which is over here. Now, these are the instructions that were used to draw the pattern below. For pattern 1, draw an equilateral triangle. Mark the midpoints, which are over here 1, 2, and 3. And then draw a color in the equilateral triangle formed by these points. So, for pattern 2, repeat this with the three triangles remaining. For pattern 3, repeat this with the 9 with triangles. Now, as you can see, the pattern is called Sierpinski triangle in one of the earliest example of fractal type patterns. Pattern 4. Now look at this pattern. It is giving you white triangles are 3, as you can see. These are 1, 2, and 3. Over here it is black. So color triangle is 1 only, which one is this one, and total triangles are 4. Now for the second pattern, we will see that it is 9, 4. So total is 13. For the third pattern, we can see there are 27 small white triangles and then 13 small triangles in between. So altogether, it's going to give you a 40. For the next pattern, as you can see, this is a n square. That means 3 square, 9 square, 27 square, and then comes 81. Then comes 40, and then a total of all these are going to be 121. This is how question number A is going to be solved. Use the number in the three columns of the table. Complete fourth. Explain. So explanation simply is that there is going to be a rule to be followed. As you can see over here, the 3, 9, 27, and 81, it is going in the square form. Okay. Now moving on to the next question, which is question number 9, 10 rather. As you can see in question number 10, it says Tom is building three different patterns with matches. He builds the pattern in steps. Step number 1, in pattern 1, it is using 5 matchsticks. In pattern 2, there are 4, and pattern 3, there are 3 matchsticks. Now, as we complete the table, step 4 for each pattern, that means that can be uh, made very easily. Now, when it comes to number of matches for the first one, it's going to be 5, and second one you can see in the step 2, it is becoming 9. As you can see, this is 5 and this is 4, and 3 is added to this. Okay, so this is the way this pattern is generated. Now, for the next one, step 3, it's going to become a 13, and step 4, it's going to be a 17 as the number is growing. And the term for this is going to be how many matches are needed for step n of patterns. That means it is going to be 4n plus 1. Okay, you understand very well how this term rule is devised. Now come how many matchsticks are needed for step n of pattern 2. As you can see, pattern 2 is different from this. And in here, the term rule is going to be 3n plus 1. And for step 3, it is going to be 2n plus 1. Now, what is the total number of matchsticks needed for step n? Write your answer simply as possible. So it's going to be 9n plus 3 after simplification. Moving on to the next question. Do we have? Or there are 10 questions? Only 10 questions for this. And this is the end part of this video. These are the answers that you should get from all these questions. And in here, I'm going to end this. See you soon with the exercise 17E, which is going to be extended part of it. In here, what you have learned is that how to generate